In recent units, we've discussed statistical inference, or using a sample to draw inferences about a population. We first did so in the context of estimating a parameter from a single population. We know that a sample statistic, say a sample mean, is an estimator for a population parameter, but it may not be a very good one because of the randomness associated with sampling. We said a better approach than just using a point estimate was to calculate a confidence interval, a set of bounds within which we have some amount of confidence that the true population parameter lies. Then we extended our study of statistical inference to hypothesis testing, where we drew conclusions about a population parameter based on a sample. For example, we collect a sample to determine whether or not the mean of a single population is equal to some hypothesized value. In estimation with confidence intervals and in hypothesis testing, we draw a conclusion about a population based on a sample from that population, and we account for three things in that conclusion: variability, sample size, and confidence. We extend this idea beyond a single population. In this unit, we'll look at statistical inference for the difference in two populations. This allows us to answer some important questions dealing with how different two populations are. For example, is this concrete formulation more durable than that concrete formulation? Is the variability in demand for product A different than that of product B? What is the difference in proportions of failed components from supplier 1 versus supplier 2, and so on? Note that we'll talk about the same three population parameters from previous units: the difference in means, the difference in proportions, and the difference in variances. A major assumption for all but one of the approaches we'll discuss in this unit is that the two samples drawn from the two populations are independent of each other. The selection of one sample from one population does not affect the selection of the second sample from the second population. Otherwise, the samples are dependent, and we'll talk about a method for handling that situation for population means. Make sure you understand the previous two units on confidence intervals and hypothesis testing for a single population. We simply extend the ideas in those two units to differences in two populations. Instead of a confidence interval for a single population parameter, we calculate a confidence interval that captures the difference in parameters of two populations. Instead of a hypothesis test for a single population parameter, we apply the same critical value approach, or p-value approach, to the difference in the parameters of two populations.